The final way we are going to be given information and asked to write an equation of a line is given 2 points. So in the activity, we had 2 points on a graph. So it says to sketch a line that passes through the given points. Okay, connect the 2 points, not a big deal. The next thing it says is to find the slope and the y-intercept. So the slope, remember, we can just count spaces for our slope. So rise over run. So rise over run, so I come up 1, 2, 3, over 1, 2, 3. So my slope, 3 over 3, but reduce that, that's just 1. So there's your slope for letter A. I'm going to do the same thing. I'm just going to keep going with my slopes here, and then we'll get to the y-intercept. So my run, 1, 2, 3, 4, 5, 6, 7, 8. And then it came down 1, 2. So make sure you make that -2. The rise, -2 over the run, which is 8. But we can reduce that to -1/4 for our slope there. So 1 here, -1/4 for the slope. Now realize in your equation, those are the numbers that are going to multiply your x, just like they always have. M always multiplies x, always has, always will. And then I can drop in there my y equals and something with x, just kind of working ahead there. And now let's go back and find our b. Right? If our slope is 1, instead of going up 1 and over 1, remember you can go down 1, over 1. That point's still on that same line. Keep counting until you get back to that y-axis. So my b is going to be 1. We said that slope is -1/4. So from this point, I can come down 1 over 1, 2, 3, 4. There's my b is 3. So again, if you drew your line nice and straight, finding where that hit the y-axis, not too bad then, or even easier, because we all know my lines aren't ever very straight when I draw them, we have our slope that we can use to count spaces. And again, remember, letter A, yes, technically we would want to go up and right for the slope of 1, but you can come down and left, change each one to the opposite direction then. So again, if I start with my slope here for letter C, I came up 1 over 1, 2, 3. So my slope would be 1 over 3. Count spaces here, over 1, down 1, 2, 3. So -3 over 1, that's just -3. So that, again, those numbers are going to multiply your x in your equations. So I can drop in there my y equals, and that number is on x. And now let's find where that's going to hit the y-axis. Up 1 over 1, 2, 3. My y-intercept, -2. And letter D, -3. So come down 3 more. Over 1. Not there yet. Down 3 more. Over 1. Now we hit that y-axis at -3. So again, for our slope, as always, count spaces, rise over run. Remember, if you ever go down or left, make that value negative. That's our slope. That's the number that always multiplies x. Our y-intercept, we can keep counting spaces with that slope until we get a point that actually hits the line. So I could go back there and actually draw in a line. I guess technically that's the first thing that asked you to do. I like to get a couple more points on there before I actually play connect the dots then. And there's your lines there. So again, if you make your lines nice and straight, connecting the 2 points, finding that y-intercept, can do it that way. But again, if your line isn't so straight, sometimes then we might seem to be guessing at that y-intercept. Can always use that slope to count spaces until we actually hit that y-axis. For the second activity then, it's doing the exact same thing. It gives us 2 points on that graph. So it says after 1 minute, we're 200 feet. There's that first point. And then after, so that's this information, because this is an X and this is a Y. Then our second point says after 4 minutes, we're 800 feet. 4 minutes, 800 feet. That's those two pieces of information. So write an equation for the height in terms of time t. So if you pay attention, our height is on the y-axis, so that's going to go where our y typically goes. So it'll be h equals, and then notice that our time is on the x-axis, so that's going to go where our x typically goes. So let's go ahead, just like we did in the other one, and count some spaces. If I come up 1, 2, 3, 4, 5, 6, but notice each one of those is in hundreds. So my slope would be 600 for the rise over 1, 2, 3. That is actually 3. So my slope would be 600 over 3, or 600 divided by 3 is 200 for our slope. So that number going to come on your t, since that's really where the x would be. Now let's count some spaces back to that y-axis. You would come up 200 over 1, or you could come down 200 over 1. So where did that guy start? At 0. You could put a plus 0, not necessary to waste the pencil. For the second part, it says use your equation. So let's actually use this h equals to find the height of the balloon after 5 minutes. Well, that's 5 minutes. That's a time, so that goes in for the t. So we're going to plug 5 in for that t value, and then we'll solve. So it'll be h equals 200 times that 5, the time. Well, 5 times 200 is 1,000, and that is in feet. So after 5 minutes, you are 1,000 feet in the air. The next one, it says after 5 minutes, the hot air balloon starts to descend. Well, go back and remember, after 5 minutes, we're at 1,000 feet. So let's go ahead and put that 1,000 on our graph. After 6 minutes, you are 200 feet above the ground. That's our other point that's on the graph. So write an equation for the height in terms of time. Let's go ahead, count our spaces for our slope. So we come over 1, down 1, 2, 3, 4, 5, 6, 7, 8. So we have -8 over 1, or our slope is just negative, and that's hundreds, right? So -800. So our equation, y equals -800. Whoop, not y, h, sorry. Forget they want it in terms of ht. But we don't have our b, and we definitely don't have room to count up 800 and over 1 and keep counting from there. So instead, let's use one of those ordered pairs that's on our graph. And it doesn't matter which one you use. We can use the one that we started with, which was the 6, 200. Or you could use that other ordered pair, which was 5, 1,000. Either one. We have a slope, we have a point. Well, that's exactly what we did in our last section, was to use a slope and a point to find an equation. I'm going to use the 5, 1,000. So my 5 will be my x, my 1,000 will be my y. So my 1,000 equals and I'm going to have to solve for my b because we don't know that, negative 800 for my m, and again the x that I chose from that ordered pair is 5. And now let's go ahead and solve. So we have 1,000 still on that left. Remember, multiply negative 800 times 5 is negative 4,000 plus b. To get rid of that negative 4,000, we'll add 4,000. So b will equal 5,000. Use your equation to estimate when the balloon lands on the ground. Well, if it's on the ground, what is its height? Well, if we're on the ground, we had a problem like that yesterday. The height will be 0. So use that equation. Plug your 0 in for the height and solve for when. That's a time. So to get that t by itself, we'll subtract the 5,000, which will be negative 5,000, and then we'll divide by that negative 800. And if you divide, not necessarily a really nice number, but we do get a decimal, 6.25. And what are our units for the x? Minutes. So it would take 6 1/4 minutes, 6.25 minutes for our balloon to land. The last one, very, very similar. We have 2 points already graphed for us. It comes from that given information, 3 seconds, 190 feet. That's an ordered pair. 1 second later, so that would be at 4 seconds, 95 feet, there's our second ordered pair. So to find our equation, if you notice from this graph, we're kind of floating in the middle of nowhere. So to actually count spaces isn't the easiest thing to do. And what we're going to see, our ordered pairs aren't always going to be graphed. So yes, we do want to find our slope, but how do we actually find slope if we can't count spaces on a graph? We use ordered pairs. So remember, we can always take that given information. Our height is on the y-axis, so our height is y values. So 190 is our y, 95 is the other y value. And then our time is on the x-axis. Well, 3 seconds, we're at 190. Here it says 1 second later. Well, it's 1 second after the 3 seconds, so that would be 4. So to find our slope, we do y2 minus y sub 1 over x sub 2 minus x sub 1. If we subtract there, we have 190 minus 95, which is 95. Negative 95 over 1, or just negative 95. There's your slope. Yet again, though, we don't have a y-intercept, but we have 2 points. Pick one of those points to plug in for your x and y, and again, it makes no difference which one you choose. I'm going to use my first one just because it's first, why not, to solve for my b. So the y value is 190, and again, this is exactly what we did in our last section, equals our m, which we just found, is negative 95, times that corresponding x value, which is 3, and now we need to solve for b. If we multiply, negative 95 times 3 is negative 285. Still have our plus b. So then add the 285. $190 plus 285 gives us the 475 for the b. So our equation then we would have y equals our m, which is the first thing we found, was negative 95. And then plus b on the end is plus 475. That 475 is the original height of our roller coaster. That was our starting height. How do I know that? Time is 0 for a y-intercept. So again, that 475 is the original position or the starting position of our roller coaster. Yet again, it asks when, so it's looking for an x value. Will you reach the ground? Well, if we're on the ground, our height is 0. So use that equation, plug 0 in for your y value, and solve for x. To get x by itself, we get rid of that addition first, so we'll subtract the 475 from both sides. And then that negative 95 is multiplying, so the last thing, divide by the negative 95. And if you divide negative 475 by negative 95, you get 5. Look for those units, seconds. So it'll take our roller coaster 5 seconds to reach the ground.